solving systems using substitution. So let's go through the steps very quickly. The first step always to isolate one of the variables in one of the equations. So variables in one of the equations. And sometimes you need to think for a few minutes, like which equations to use and which variable to isolate so that later the work is easier. You want to be wise about it. The second step is to substitute this expression into the other equation and solve for the remaining variable. The next step is to substitute your answer back into one of the original equations and solve. And then remember to write your answer as an ordered pair. Right? Because when you solve this system of equations, you have two variables to solve for, so you want to be very formal about your answer. X, y equals there. Okay, let's go through this simple example. Find the intersection points of the following equations using substitution. So basically solve the system. Okay, the first step is to isolate one of the variables in one of the equations. Which variables should we isolate and which equations should we use? Dylan? Well, if I look at the second one, y is already isolated for me, right? So I can just kind of skip the step because it's done for me. Y is already isolated. So the first step is done. Y equals 3, right? Isolated. So the second step, what do? Substitute this expression into the other equation and solve for the remaining variable. Yes, I think. Yes, exactly. So if I'm just, rewriting my first equation, 2x plus, and then I have this y here, right, equals 7. So instead of y, I could just use my 3. So I substitute 3 instead of y. So I rewrite 2x plus 3 equals 7. And now I solve for x. How do I solve for x? Huh? Minus 3 minus 3.
Divide by 2.
And then divide by 2. So 2x equals 4. And then I divide by 2. And then I have x equals 2. So I solved for x. Well, in the steps, I have substitute your answer back into the original equations, into one of the original equations and solve. But do I need to do this here? Right, because I already have the answer for y. I can kind of skip the third step altogether because there is nothing to solve for. I already have answer for y. So the third we just skip, and then we finally write our solution as the x, y here equals, what is it? 2, right? So that we are very clear about what we solved for. X is 2 and y is 3. That is our solution. This is my final solution. Questions? Let's try another one. X squared equals 8y. X squared equals 2y plus 12. Okay, so what do we do? Which variable should we isolate? Let's be smart about it.
Equal 8y to 2y plus 12 and then solve for y.
Yes, so what Mary is saying is we could isolate x squared, right? Right? Because we don't have to isolate x, we could just isolate x squared, right? So in the first one, we know that x squared equals 8y. And now we can use this expression 8y and substitute it for x squared in the second equation. So I write the second equation right here, and then I use my 8y instead of x squared in the second equation. Right? Can I do that?
again.
X squared isolated, not my variable x, but x squared, and then I substituted y for x squared in the second equation. So I rewrite 8y equals 2y plus 12. And now I can solve for y. So what do I do? Minus 2y on both sides. So I have 6y equals 12. And then I can divide by 6. So y equals 2. So I solve for y. Now what do I do?
So then you take 2 and plug it into the top equation. So x
Exactly.
squared equals 8 times 2.
Plus or minus 4.
Yes, so x squared equals 8y. And now take my solution for y and plug it in instead of y. So I have x squared equals 8 times 2, which is x squared equals 16. How do we solve this? Square root method. So square root of x squared equals square root of 16, and I don't forget plus and minus because there are two solutions. So x equals plus or minus 4. Okay, so now carefully, what are the solutions? How many solutions does this system of equations have? 2 solutions. Because each solution is in order clear xy, right?
So there's 4 and 2 with 4 coming first.
Right, so my answer is xy equals what? Isaiah, what were you saying?
4,
4, 2, and my second answer is
Negative 4, 2.
negative 4, 2. So there, it's not like we have 3 solutions. It's 2 solutions. Each solution is the ordered pair.
So you have 2. The second one that says negative 4, the reason why you have that is because of the square root.
Yes. Questions about this? Okay, let's do the next one. Two equations. How many solutions do you think we will have? Hmm?
2.
If I craft this, what are my shapes? The first one is line, the second one is line, right? So when I have 2 lines, how many solutions can I have?
1.
Either 1 when they cross, none if they're parallel, or infinite number when they are, overlap, right? So never 2 solutions. Either 0 solutions, no solutions, 1 or infinite. Okay, so let's solve using the substitution method. What do we isolate? Lillian, how do we start? We need to isolate one of the variables. Anything works. We could do one or another. Which one is easier from which equation? I can isolate y from which one I will use? From the first, right? It's always easy to isolate when the coefficient is 1, right? So I don't need to worry about like any fractions or anything. So let's use the first equation, 2x plus y equals 1. And I want to isolate y. So I do minus 2x to both sides. And now I have y equals 1 minus 2x. Great. So now what do? I substitute this expression into the which equation? The other one, right? The other one. I already used the first one, now I need to use the other one. So x plus 3y equals 13. So I take this expression that I got for y and I substitute it for y in the second one. So I write x plus 3 times, and instead of y, I put 1 minus 2x equals 13. Now I can solve for x because all I have is one equation, one unknown, right? One variable. So what do I do? Yes. Yes, honey. are saying why don't you solve it by graphing?
No, what the two is
Could you repeat the question? No, just repeat the question.
I forgot what it's called, but when you graph it, you put x plus 3 equals 13, and 1 minus 2x equals 13. Would you want to do that?
So y minus 2x equals. No, I'm sorry, I'm not following.
It's okay, never mind.
No, we can work through this.
Go
No,
on,
okay,
please.
okay, okay. Maybe you can help. I don't understand the question. Okay, so sorry, Hannah. Okay, so I distribute, right? I first simplify this. I have one equation, one variable, so I distribute. And I write x plus b minus 6x equals 13. Right, so I combine the like terms, x minus 6x is minus 5x, then I still have 3 equals 13. And then I subtract 3 from both sides, so I have negative 5x equals 10. And then I divide by negative 5, and then I have x equals negative.
Lunch.
So why don't they have right there on the left one, that one of the solutions?
This one?
Yeah.
No, it's not yet a solution, right? Because we have expression for y in terms of x, but we are looking for a number, right? So we are not done yet. Okay, so we solve for x. Now what do we do?
Lunch.
No, 2 minutes. Give me 2 minutes. 1 minute. So now I can use the solution for x, plug it in either into one of the original equations and solve for x, or I can just use this, right? See, I have y in terms of x already. So if I just take my x and put it here, I have my y, right? So y
equals 5.
1 minus 2 times negative 2. So I solve 1 minus negative 4 is 1 plus 4, so it's 5. Correct? Very good. Yeah. And now we need to
Negative 2, 5.
yes, so my final answer, x5 equals negative 2, 5.
See, now they know the answers. They want to go lunch.
Exactly.
Good job, guys.
Food motivates the mind.
I know, it does, doesn't it?
Yeah, that's all I got.
Okay, so let's do this one together. Y minus x squared plus 2x equals 4. And then 3y minus 3x squared plus 6x equals 10. Okay, same method, substitution. So what do you think we should isolate and from which equation?
You could either do y or x.
Y or x? Which one is easier? Luis, you want to say something? We'll use the top equation, and what do you want to isolate? X or y? Huh? X? Which is easier? Yeah, no, I'm looking at Luis. I see you're saying X or Y. Right? If I try to isolate X, I will have the quadratic equation to solve right away, right? And then I will have this monster, like whatever, with the plus or minus, and then I'll have to substitute. It's too much work. Y is a little bit easier to isolate, right? There will be just one solution for Y. So let's do that. Let's use y minus x squared plus 2x equals 4 and isolate y. So what do I do?
Did you do that right?
Subtract 2x. So y minus x squared equals 4 minus 2x. And now what do I do? Plus x squared to both sides.
One of them says minus x squared. Under it.
Oh, it's plus. Oh, I make so many mistakes. Okay. So y equals 4 minus 2x plus x squared. Okay, so we isolated y, right? Now what do we do? We substitute. So which equation do we have to use? the bottom one, right? If we use the first one to isolate, we have to use the second one to substitute. So 3y minus 3x squared plus 6x equals 10. Right? So I take whatever I got for y and I substitute it into the second equation. So let's see what happens. 3 times, instead of y, I just use this whole thing. I just use that one. 4 minus 2x plus x squared. Right? You see what I did? I used the expression for y and put it in the second equation. And then I have minus 3x squared, so that's hidden over 6x equals 10. Now I need to simplify this. So I distribute 3 into the parentheses. Remember, we have to distribute, we have to multiply every term that's in parentheses by 3. So 3 times 4 is 12, minus 3 times 2 is 6, so minus 6x, and then 3 times x squared is just plus 3x squared. And I still have minus 3x squared plus 6x equals 10. Right, to fit in that. Yeah. Okay, so continue. I combine the like terms to simplify as much as possible. So what are my like terms? I have negative 6x, positive 6x. Minus 6x plus 6x.
0.
3x squared minus 3x squared.
0.
0. So what I have is 12 on one side and 10 on another. 10 equals 12. 12 equals 10. Yes, exactly. What does this mean?
No solution?
No solutions, because after I did all this work, I have the equation that never works, right? It can never be true. Whatever x and y I choose, I get 12 equals 10, which is like false statement. Yes.
So the whole answer for this whole problem, both equations,
No solutions to this system, right? Each equation separately has many solutions ordered per y and x, right?
as
X,
a
y.
whole is
But the system has no solution. So if I graphed these two equations, right, on the graph calculator, what would I have? What picture? What forms or what shapes would I see? For the first one, what is this shape? Parabola. For the second one, parabola, and they would never intersect, right? One is probably upward facing, another one is downward facing, and one is on top of the other.
Do you call those parallel?
No, those are not parallel parabolas. They probably look something like this, right? Never intersect. Okay, no solutions. Are we ready to try this one on your own? This is easy, right?
Very easy.
This is linear, so try. Start the recording. So everybody got to this part. So everybody isolated either x or y from the first equation. Right, so I'll isolate x, so it doesn't really matter. X equals 6 minus y. And then you use the second one, and you substituted what you got. Right, so 3 times 6 minus y equals 3y equals 18. So you distribute, oops, not equal. Okay, then you distribute it, you simplify it, and everybody pretty much got to this point. 18 equals 18, right? So we must start our equations, we try to solve, and we got equation that is, when is this true? Ever? Always?
Always.
Always true, right? So it means that our system of equations has how many solutions? Well,
all solutions that are within
infinite number of solutions. And this is why I hate the word in all real numbers, because if I just pick any random pair of x, y, this will not be solution to my equation, right? If I just pick like random 1, 2, maybe I got lucky, but let's say 1 plus 2 is not 6, right? So my pair, which I randomly picked, doesn't work for my equation.
anything that's on the line.
On which line, right? So that's the thing. I could pick any x, whatever I want. Let's say I pick 1. And I will be able to find y so that my pair works. Right, so if I pick 5, because 1 plus 5 is 6, then 3 times 1, 3, plus 5 times 3, 15 equals 18. Right? So for any x, I will be able to find y so that the pair works. So there is infinite number of x's I could choose, right? So there is infinite pairs, infinite number of solutions to my equations. Not any random pair, but infinite number of solutions. Graphically, what this would mean, if I put these two lines into my calculator, what would happen? How many lines will I see? Just one line, right? And it's very easy to see actually for this particular one. If I multiply this whole equation by 3, right, what happens? Multiply the left side by 3 and the right side by 3, I will have exactly the second equation, right? I will have 3x plus 3y equals 18. They're exactly the same lines. Overlapping lines means infinite number of solutions. Good? Okay. Okay, so next one. You want to solve by yourself?
Yes.
Yes. So if you need help, listen up. If not, you can continue doing what you're doing. So I will use this second equation. Oh, I should not talk, right? I should just silently solve. I can talk.
What is it? Is that take your ears?
Okay, everybody got to this part, right? Everybody has the quadratic equation,
Yes.
right?
Yeah,
So now so now what do? We just solve for x. And we need to remember how we solve quadratic equations. Yeah, the easy way for this one is factoring because the coefficients are so nice. So I do my T chart with negative 54 and 3. What are my numbers? Negative 6 and 9. Yeah, that works. So I just rewrite it x minus 6, x plus 9, and I set the whole thing to 0. And how after I factor the trinomial, how do I solve?
So you take equals 1 of each, so you take x minus 6 equals 0, so x equals 6.
Yes, exactly, because you know what this means, right? I have one number multiplied by another number, so this one multiplied by the second number equals 0. At least one of those numbers has to be 0. Otherwise, I have non-zero times non-zero wouldn't be 0, right? So at least one of the factors has to be 0, so it's either x minus 6, 0, or x plus 9, 0. Yes, so x equals 6 or x equals negative 9. Did I solve my system? No, not yet, because the system has two variables, x and y, right? I have two answers for x. How many different answers will I get for y? Two different ones, right? Because what I need to do is, let me do the zoom. Right, what I need to do is here, I need to plug in each of these x's and solve for y. So I'm just going to use these you know, whenever I isolated y, I can use this now, right? So if x equals 6, then y equals negative x, so negative 6 minus 20, right? So this is what I used. I took this one and just solved. And that gives me y equals negative 6 minus 20 minus 26.
Why do you have negative 6? Oh, yeah.
Right? So from negative x to minus 20. So my first solution is what? Xy equals what? 6, right? My x is 6, my y is negative 26, right? That's my first solution. So for the second solution, I need to use the same formula for y, but plug in the second solution. So y equals minus negative 9 minus 20. So my y is 9 minus 20, negative 11. So the second solution would be what?
Negative 9, comma negative 1.
Negative 9, comma negative 11. Sorry, it's kind of all here together. So this is my final answer. You can see, right? So here there are two solutions.
Say on a test and you don't put like 4, you just have the 2.
Oh, that's fine. Just make sure that we understand. No, you have to put like, don't put or necessarily, but have them in ordered pairs, right? So you have xy equals 6 minus 26, right? So you know that, we know that you understand that you are solving for two variables, x and y, right? And they're dependent. Questions about this? Okay, so we are ready to look at the second method. To solve a system using elimination. How do we do this? So you have two equations, right? The first step is you create the opposites for one of the variables. Create opposites. One of the variables. And then you add the equations together. Now solve for the other variable. And then plug the value back into one of the equations. And solve. As before, write your answer as an ordered pair. Okay, so the first example. 2x plus y equals 7. So the whole idea here is to add the two equations together, and as the result, eliminate one of the variables, right? To get a new equation that will only have one variable. Right? You've done this before, right? You know what I'm talking about. You don't need to go into this in details, right? Or no? Are you following? Okay, okay, so here, what I wanted, I have two equations, and this is the first step. I want to create that opportunity that we just talked about. I want to be able to add the two equations so that I can eliminate one of the variables. So I need to make sure that I have, my second equation has y but doesn't have x, so I know that I need to eliminate y, right? So what do I need to do to this to the second equation so that I have, make it opposite. So what do I need to do to both sides of this equation so that my coefficient in front of y is opposite from what I have at the first equation? I can multiply or divide by -1, right? So I can multiply this by -1 and this by -1. And then my whole system will look very differently. Well, not very differently, but instead of y, I have -y, and instead of 3, I have -3. So that was my first step. Make sure that I have opposites for one of the variables in two equations. Now I can add the two equations together, and what do I have? 2x plus y minus y equals 7 minus 3. Right? So y minus y cancel out, I eliminate y, so I have 2x equals 4. And now I solve for x. I divide by 2 both sides, and now x equals 2. Right?
And then we solve for y, right?
Yes, so now I still need to find my y, so what do? I take one of these equations, plug in my x, and find y. But do I need to do anything for this particular one?
No.
No, because I already know what my y is, right? Y is 3. It's kind of that for me. So y is 3.
You can use both interchangeably.
So this is my final answer, or actually I should put it in this. X, y equals 2, 3. That's
You
the
can use
answer.
them interchangeably.
Questions? No. Too easy?
No.
Okay, so let's try this one. X squared equals 8y. X squared equals 2y plus 12. So, what do we do here? How do we eliminate one of these?
You can add
Divide.
12 on the bottom. You can to get y by itself.
I could do that for the substitution, right?
Oh, right.
But now we are talking about elimination. So how can I easily eliminate one of the variables?
Divide -1 on the top one.
So I can do that, right? I can divide or multiply the first equation by -1 again. Right, so -1, -1. So I have minus x squared equals -8y, and then the second one stays as this, x squared equals 2y plus 12. Now I have two equations, and for x I have the opposite coefficient, right? -1, 1. So if I add these two together, minus x squared plus x squared will go away. I eliminated the x squared, and I have -y plus 2y plus 12. Right? So now I combine like terms. -8y plus 2y is -6y plus 12. I can solve for y.
Add 6y.
Plus 6y plus 6y. 6y equals 12. Now I divide by 6 divided by 6. Second y equals 12. Oh. Oh. How can I delete everything together? Can delete. Y. Am I done? No, I still need to find x, right? So I take my solution for y and I substitute it into any of these two equations. Which one should I choose? First one, because it's smaller. So 8y, and I take my y and substitute it here. So x squared equals 8 times 2. So x squared equals 16. How do I solve this? Square root. I don't forget plus minus. X equals plus or minus 4. How many solutions do I have? 2. So how do we write them? The first solution is xy equals what?
4 comma 2.
4 is very fancy.
Love it.
Okay. X equals xy equals 4, 2, and then my second solution is what?
-14.
-14. Questions? Okay, so this one, the coefficients are different from 1, right? Before you always had like just 1. So this one, 2x plus y equals 1, x plus 3y equals 13. How can I modify one of these equations so that I have opposite coefficients for one of the variables? Q. What do? I want to have either for x or for y, I want to have the opposite coefficients. So what do? Who has an idea? Jacob. Wait. And well, look at this. If I just have x plus 3y, right, 13, don't do anything to the second one. What do I need to do to the first equation so that I have minus 3y here? I want the opposite so that when I add, I eliminate y. Yes? No. Right, so what can I...
Times negative 3.
Times negative 3, right? So if I have 2x plus y equals 1 and I want to do something to both sides of this equation so that I have minus 3y, right? I can multiply everything by negative 3, right? The whole equation. So I would have to multiply right side and left side by negative 3, right? Can I do that? Yes, so I multiply 2x plus y with negative 3. So negative 3 times 2x plus y. And then I need to multiply the other side by negative 3, right? So then I distribute, and what do I have? Negative 6x minus 3y equals negative 3. Correct? I took my first equation, multiplied both sides by the same number, negative 3. And now I have something that works very well for me, right? Negative 6x minus 3y equals negative 3. So now I have two equations and I have minus 3y plus 3y. So if I add the two together, when I add left side, I have negative 6x minus 3y plus x plus 3y equals, now I'm adding the right side. Negative, just leaves its own life. There is no y suddenly. Color change. Okay, so negative 3 plus 13. See what I'm doing here? I'm trying to eliminate y. So minus 3y will cancel with plus 3y. And what I have is negative 6x plus x. So negative 5x equals negative 3 plus 13 is just 10.
Sorry.
Yes. Oh, that is why something is happening first. Okay, so now I can solve for x, right? I can divide by, negative 5. Leave it colorful. Okay, so x equals 2, negative. So I solve for x, right? I modified the first equation so that I could eliminate one of the variables. I added the two equations together. One variable went away. I solved for x. Now what do I do? I still need to find what? Y. I still need to find y. So I need to take my x and plug it into one of the equations. Which one? Bottom, top. Doesn't really matter, right? So I take the first one. Well, maybe bottom was easier, so I don't have to divide anything. But it doesn't really matter. So let's take the second one. Oh no, actually no, the first one is easier. Okay, so 2x
Yes, it is.
plus y equals 1. Right? So I take my x, the one that I found, and plug it in. So 2 times negative 2 plus y equals 1. Now I solve for y. So I have negative 4 plus y equals 1 plus 4 on both sides gives me y equals 5. Right, so I found my x, now I found my y, and I combine them into the solution. xy equals negative 2, 5. And that is my solution. Questions? Lots of steps, right? But they're kind of intuitive, no? Kind of.
Do you guys see what just happened? Like if I
Yeah.
like something real quick. So if you gonna be okay. So you have a problem like this, and the thing is you have to use elimination because we said, you know what, use linear combination. All right. So here's the thing. These two equations these guys are a little bit weird because we have a y, we have an x squared, and we have an x, right? We have like 3 different things going on here, right? So whenever that happens, guys, get rid of the one that is not like the other ones, right? You gotta get rid of the y's, okay? Because the x squared and the x are similar, but the y is not. All right, so I have to look at my y's. I have y and I have 3y. Okay, the second y has a 3 in front of it, positive 3, right? So what should I do to the y that's on top?
-3.
Okay, I want to make it -3. Yes, what is, yes?
What happens when you put that -3 in and everything just collapses because of it?
All right, I don't know what kind of a situation that would be
No,
right now. Hold
It's
on.
-3 over 3, positive 3 over negative.
Okay, all
It's-
right, okay, all right.
Words.
So, all right, we'll see. Okay, so here's what you guys said. Okay, to get rid of these, since this one on the bottom is positive 3, I have to make the top one a -3. You can't just go and change y. If you change y, you gotta change everything. So I'm gonna multiply the whole thing by -3. That means distribute it to everything, okay? So then this first equation becomes -3y plus 3x squared minus 6x equals what? Okay? And the second one, do we do anything in the second one? Nothing, not a thing. Keep it the same. Let's just write it over. All right? After you get one of your variables, make them have the same number, opposite signs. Then you're going to add everybody, right? And since they're lined up so nicely, all you have to do is just add it down, right? What's -3y plus 3y?
0.
Good, and it should be because that's the one that we targeted, right? That one's the one that we wanted to get rid of. Okay, so that goes away. What is positive 3x squared minus 3x squared?
0.
Oh my goodness, what is happening? What is negative 6x plus 6x?
-0.
Let's
Zero.
spice it up.
And look at that, equals, what's negative
-2.
12 plus -2? Oh my, is this true?
No.
No, this is false. So this is what?
No solution.
Yes. Okay? Guys, if you ever have a situation where you have like an x squared, an x, and a different variable, keep that squared and the x, you know what I mean? Like that plain variable term, keep those there, okay? Got to get rid of the one that isn't like the other ones. So then let's try this one, okay? So I'm looking at this, and you know, so I have the x's and I have the y's, right? This one's just you pick whichever one you want to, and let's make them have the same number but opposite signs, right? We don't have any squares or anything, so this is nice. Which one do you want to make have the same number, opposite signs?
Top.
The x's? Okay. So if you look, the bottom x already has a 3x, so the top one needs to become, okay, so multiply that by -3. And then let's rewrite this. So then that's -3x minus 3y equals -18, yeah? Bottom one, we didn't do anything. Oh, I see where this one's heading. What is this?
Oh, real
0
numbers.
equals 0.
Oh,
And
real
then you
numbers.
add them. That equals that. Nope, 0 equals 0. Is this true?
Yes.
Yeah. So this is,
Oh,
what does
real
that tell me
numbers.
about infinite,
Alright.
right? So infinite number of solutions. Yes? Let's get to one that's like good. Yeah, let's get to a normal one. Okay? So boring. Okay. You know what?
Yeah.
we do that one? Let's see. Okay. Yeah. All right. Let's do this one. So these problems are good because they look very similar to the ones that you will see on the SOLs. All right. First off, make sure that you read the directions because it says identify the x coordinates. Okay. I know we said you have to find the x comma y, but these problems they're only asking you for the x. All right. So, okay. Did it say we have to use any particular method? No. All right. Since I'm looking for the x, well,
Times the top by -2.
look at this. They're both equal to y. If they're both equal to y, then they can be equal to what?
Each other?
Each other, right? Because if all of this equals y, and that's the same y, you see what that, yeah? Then you could do x squared minus 6x plus 5. Yeah, and this works out perfectly for me because I'm solving for the x's anyway, right? So, guys, this looks like a trinomial. Anytime I have a trinomial, I need to solve by factoring. We'll try to solve by
Why
factoring.
can't we just make it tinier first?
I know. That's what I'm getting
Oh.
to, right? I mean, you guys are sass, man. Just a whole lot of sass.
No, it just
Mary.
A
no,
lot
you just
of sass.
it sounded
Not just
weird.
you, but yes, there's a whole lot of sass going on. Can I take my time with this a little bit? All right, move everything over. Okay,
Yeah, you
they're
good,
rushing
Miss
me.
Don't let her.
All right, there we go. You guys are rushing me. Okay. 2x squared minus 1x squared gives me what? X squared. Negative 12x plus 6x gives me 13 minus 5 gives me what? Right? Okay, so now look at that. And, you know, this is actually a really nice trinomial because it's just a plain old x squared.
4 and 2.
Yeah, two numbers I multiply to give me a positive 8 and adds to give me negative 6 is negative 4, negative 2, right? The reason why I could go straight into my double parentheses is because this was just a plain old x squared, right? You could do it the long grouping way, and that's fine. All right? So now what do I do, guys? We did this in the last unit. How do I solve for these x's?
Equal to 0.
Yes, do your little mini equations here. Everybody gets set equal to 0. So then x equals 4 for this guy, and x equals what? 2 for that guy. Do we need to go and solve for those y's? No, because they just wanted the x's. Well then, 4 and 2. There you go. And you're done with that one. Okay?
Can we sleep now?
No. All right. Let's try the next one.
This is a kindergarten.
I tried.
This one says identify the y coordinates. Okay. So if we're trying to get the y's, all
Well,
right.
I know how to make. Wait, I know how we can equal it to each other. I know.
Okay. How?
No.
What did you do?
Add the 2x over to the other side and then divide the 2, and then you've got y equals negative x plus 5, and then you can equal those to each other.
Yeah, you know what? This has an x squared, Mary. So since it has an x squared, unfortunately with this one, you have to solve for the x's and then you got to get the y's, right? There's no other way, right, Ms. Star? I wish I could say there's no other way. So what we're gonna do is, you know what? Let's just do substitution.
Yay.
You want to do substitution
Have
with
fun
this,
with it. Yes.
or do you want to?
Can we please just do it the easy way?
Yeah.
The easy way.
Yeah, then let's just solve this for y. Because I'm seeing the negative 2, 2, and 10.
Yeah.
Alright. Okay, so what is this? 2y equals 2x plus 10. Divide everyone by 2, right? y equals x
Substitution.
plus 5. Do you agree? So what I did was I rewrote this guy to this.
Mhm.
Yeah? So now take this y, plug it in, right there. Right? Because you can't plug it back into a cell. Make sure that you plug it into the other one. So then now we have x plus 5 equals x squared plus 7x plus 13. Ooh, trinomial. Move the x, move the 5.
Honey, either way you kind of do AM.
Yes? All right. Factor this. This is AM. Two numbers that multiply. Oh, we just did this, didn't we? Yeah, 4 and 2. Right?
Mhm.
Okay. So then everyone gets a mini equation. X plus 4 equals 0. X plus 2 equals 0. X equals what?
-4,
X equals -4 and x equals -2. Okay, but I don't want the x's, I want the y's. So I'm going to plug these guys into this equation. This one, that one. So y equals -4 plus 5. So y equals what? 1. Yeah. Sorry, I know I'm kind of rushing through this. -2 plus 5. Y equals 3. Good. So, sometimes you can't go directly to the coordinates that they're asking you for. You have to go through all this. All right? We have a homework assignment for you guys that looks at, solving systems algebraically using substitution and linear combination. But you guys are also going to be given your test review today. So you can start on it. Oh, and you have it. Perfect. So if you did not get it, it's up here.